Hi, this is Samasam, Assistant Professor in the Department of Mechatronics Engineering at SNS College of Technology. I welcome you for another videos which is related to engineering drawing. So everybody knows basic concept of drawing. If you have any queries, you can check with my previous videos how the engineering drawing has been evolved. Today we are going to discuss about the projection of cone. So the normally the cone is revolving prism, revolving pyramid, right down. So it works based on how it has been projected in the first angle, second view, and top view, section view. That has to be discussed here. So this is the video which I can explain through an Solidus software. So I would like to share the Solidus software for the clear understanding of the concepts, right. So as I said earlier, this is the engineering drawing class. So I have to draw a one straight line representing an XY plane. So I'm going to mention this as an X and this as an Y. Similarly, the upper plane part will be considered as vertical plane, the lower part will be considered as horizontal plane. So when I come to I have to be in a zoom position. So I like to take this view and zoom particular area. So I'm going to zoom this one. So now I'm going to draw a cone. So the cone, normally the cone is a round-like structure where the upper part is an apex where it's joined by using a revolving surfaces, right arm. So now I like to draw a circle. So directly by using a center point, right arm. So by clicking here, I like to mention what is the diameter. So the part here will be mentioned as diameter. So my diameter will be a 40 mm diameter. So I draw the circle of 40 mm. So I kept the circle and drawn the circle. Now I like to make an intersect points, right. So I have to draw the intersect because for the cone clear understanding we have to draw the intersect points. So now I have drawn the intersection points, which this will be the cone's top. This will be of initial position of the cone, which is kept in an on horizontal plane, which is axis parallel to a vertical plane. So now I have to draw a trace line from point this one to this one. Similarly, from this to this, and similarly from this to this. So as I said, these are the traces lines. So I like to make this as dimensionless things, and in a different color I'm going to mention is in red color. So this is the trace line I have to draw. So before that I have to mark it this as A, this as B, this as C, and this as D. Finally the midpoint will be represented as O. For visibility, I drag this into upsides. Okay. Then, as I said, from this point, the axis height is 50 mm. So I have to mention this as 50 mm length. So I draw this line. So as I said, that this is an axis line. So I am going for an axis line. So this will be your axis line with the dimension of 0.18 of length. Now I am going to draw the slanting part of the particular object. Similarly, from this point I am to draw, and similarly from this edge I am aspect on. So this is your final projected view. When I looking from front view, the naming will be marked as this will be your A dash, and this will be your D dash, because there is only one point. But here, when I see the B is visible and D dash is invisible. Similarly, the apex will be your O dash. Now I like to rotate this one. Okay, so one of the slanting edges has to be. So I am using the rotate option. If I can't able to find here, then there is no problem. View toolbars, you can manage the tool, and customize option. You can see there is a options which we cannot able to view in the particular view. So I like to search the tools. What are the available tools? So I am searching here. So dimension tools and animation tools is there, and text tools is there, drawing tools is there, modify tools is there. So I'm using this button as rotate option because this happens rotates elements. So I'm using this option and drag down here. So the rotate option is already pasted here. Now I'm using this rotate option from this point, right? So and the angle position will be 0. From this will be rotated till this one. So where I have to rotate, we have to click both the hands, then we can able to rotate. Then I have to transfer these lines to some extent. So I rotated and kept placed here, right? So again, we have to mark this as, so the rotate plane is C dash, this one is O dash, this one is A dash, this one is B dash bracket D dash. Now I have to draw the trace lines from here with a less dimension, right, and different color of red color. So again I am drawing the trace line here. Similarly, from this point to as a vertical line, I am drawing a trace line from similarly from A to bottom of this in a straight line. Similarly from O dash. So every point I have to draw a trace line. Similarly from here D dash to, similarly on the line passing from C, we have to draw the trace line. Similarly from B to C. This is how the trace line has to be drawn. When I using terms of the excess lines has been removed, right now. So this will be your trace lines as, for clear understanding, the trace lines should be there. So I keeping there such as, then I am going to draw a line with a thickness of 0.35 with an black color right now. So whenever the point meets the DD, this will be your considered DD dash. So when I remove this one things, this is your final projected view, right? So I'm going to draw from this one D dash to here. Similarly from here to here. Similarly the surfaces are from this point to this point. So but when you see that it will rotate like a rectangle, right? But we need a spline. So I'm going to draw this as a semicircle, right? So it's a like circle with a center point. So this will be center point. This will be center point. So I'm going to draw this one. This is your final projected view. Then I'm going to draw this text as where are the point means. This will be your the point D. This is your D1. Then we can make it as P. We make it as this as P. This is Q. This is R. This is S, and this is P. So the final projection. Hope everybody has understood how the projection of cone has to be done. This is the final projection view of projection of cones. I will catch up in the next video with another topic. Until then, bye bye. Signing off by Sambasam, Assistant Professor, SNS College of Technology.